a mole means in chemistry. And so when we say moles, we do not the animals, they're not the skin deformation, but we have chemistry moles. So a mole in chemistry is a unit of amount of substance. Remember when we talked about SI units, the amount of substance, the SI unit is a mole. And so this guy named Avogadro figured out that 1 mole means it contains 6.02 times 10 to the 23 atoms or molecules. And again, so Avogadro was a chemist and he figured this out, I think in the 1300s, maybe 1400s, and so it's called Avogadro's number. And that would be 6.02 times 10 to the 23. And it is also a conversion factor because 1 mole equals that many atoms. So when I say I have a mole of something, that means I have 6.02 times 10 to the 23. And that's a big, big, big number. Remember, a million is times 10 to the 6th, and a billion is times 10 to the 9th. So times 10 to the 23 is like a billion, billion, billions. So it's a lot. Okay, and your fun fact would be that 1 mole, so remember a billion, billion, billions of donut holes would cover the earth and you would be 5 miles deep in donut holes. So again, a mole of atoms is actually really small, but a mole of donut holes, it would be pretty big, and a lot of donut holes, and we'd all be dead. So remember that we're talking about conversion factors. So pause the video right now. On the other side of your notes, the interactive side on the left-hand side, I want you to write down this 1 pair equals blank, and I want you to try to fill it in based on what you know. Okay? So pause the video and go ahead and write that down and do that. Okay, so again, I hope you did it instead of just continuing on. So you write 1 pair equals a dozen objects. Oh, sorry, 1 pair equals 2 objects. Okay, 1 dozen equals 12 objects. 1 ream is actually 500 objects. So a ream of paper means it has 500 sheets. And then 1 mole is just like the rest of them. It's just like saying a dozen. A mole means you have this big number, this Avogadro's number, 6.02 times 10 to the 23rd. Okay? So, a conversion factor, we can use it to convert from atoms to moles, number of atoms or anything to moles. Okay, so the way we do this also is through something called molar mass. Molar mass of an element is how much 1 mole of that element weighs. So the molar mass is actually equal to the average atomic mass. It's kind of funny how that works out. That's why we actually use it to average atomic mass. So again, where do you find the average atomic mass for an element? Well, you look at your periodic table and boom, there it is. That number at the bottom is your average atomic mass, and that means that is how much 1 mole of hydrogen weighs. 1 mole of hydrogen weighs 1.008 moles. Okay? So, moles are going to be super important for chemistry. Maybe one of the most important things we do in chemistry because they are going to be how we know how many atoms are in a sample of a chemical. If we know how much a chemical weighs, we can calculate how many atoms there are. So this is very important. So for this next part, I want you to open up this website in a separate tab, www.webelements.com, and it's a periodic table, so you can follow along as we do this next part. So here's an example of questions. 1. How many grams of lithium has 1 mole in it? So how much does 1 mole of lithium weigh? Well, we're going to come over to our periodic table, and over here I find lithium right here, and the mass I read is 6.94. Okay? So 6.94 I'm going to actually round up to 7. So 6.94 grams or 7 grams. On all of these, you want to round to the half. So if it was 6.5, I would round to 6.5. Or 6.4, I would round that to 6.5. But it's 7. Okay? How many grams for mercury? So again, we're going to come over here. Here's mercury. Hi, mercury. We see down here 200.59. Okay? Again, 200.59. I'm going to round to the half, so 200.5 grams. Okay? 1 mole of sulfur is how many grams? So how much is 1 mole of sulfur going to weigh? So again, come over here. Here's sulfur, and it says 32.06. So I come back here, 32.06 or 07, and I'm just going to round that to 32 grams. So that's molar mass. Pretty simple. It's probably one of the easiest things in the world. And now, molar mass is also a conversion factor. So now we have two, Avogadro's number and molar mass. Molar mass is going to take us from mass to moles. So if I know how many grams I have, molar mass can tell me how many moles I have. And then once I know moles, Avogadro's number can tell me how many particles I have. Okay? So here's some example questions with that. And since we're talking about conversion factors, this is where dimensional analysis is going to come back into play. And I know some of you were thinking dimensional analysis was a thing of the past, but remember I told you it was going to come back. So here's where it comes back. And we're going to be using this the entire year. So number 1, what is the mass of 2.5 moles of lead? Okay, so first you need to know how much 1 mole of lead is. So I'm going to come over here to lead, and lead is right here. And so I see 207.2 is the molar mass. So 1 mole of lead is 207 grams. And here's my dimensional analysis track. I got 2.5 moles on the top, right, because it's from here. And then 1 mole of lead is 207 grams. The moles cancel out, and I'm left with 2.5 times 207 gives me 520 grams of lead. Okay? And remember significant figures, 2.5, that's only 2, so I left only 520. Okay, the next question, number 2, says, how many moles are in 32.6 grams of sodium? Okay, so again, I need to come over here and look at sodium. Sodium tells me 22.9. So that means over here, my conversion factor for molar mass is going to be 1 mole equals 23 grams of sodium. So here's my track. 32 grams of sodium on the top, 23 grams of sodium on the bottom equals 1 mole. And so grams and grams cancel, and 32.6 divided by 23 gives me 1.4 moles of sodium. So 32 grams of sodium is 1.4 moles. And remember, once I have moles, then I could calculate atoms, because 1 mole is 6.02 times 10 to the 23 atoms. So if they ask me that as a second question, I could do that pretty easily. So, last question is kind of based on that. So, how many moles of atoms do you have if you have 2.7 times 10 to the 24 copper atoms? Let's say that you were a busy bee and you sat there and counted a bunch of atoms in a block of copper. And you knew that there's 2.7 times 10 to the 24. Well, first, again, you need a conversion factor. And remember, it's just Avogadro's number. So 1 mole equals 6.02 times 10 to the 23 atoms. So I plug that into my track. 2.7 times 10 to the 24 atoms of copper up here. And then atoms of copper needs to go down up here, and so atoms of copper goes on the bottom. 6.02 times 10 to the 23. And that equals 1 mole. So 1 mole goes on the top. Then atoms and atoms cancel out, and 2.7 times 10 to the 24 divided by 6.02 times 10 to the 23 gives me 4.5 moles of copper. So that is moles. It kind of takes a little bit getting used to, but if you got dimensional analysis down, it's really easy. And all you have to do is remember a couple conversion factors and how to look up a mass number or the average mass on a periodic table. So on Monday and Tuesday, we're going to be working on mole problems and talking more about moles. So make sure that you understand this video. If you need to watch it a couple times or go back and play a part, feel free to do that. And I will see you then. Have a great 3-day weekend, guys.